Hello and welcome to another video. In this one, we're going to talk about atomic removal or replacement of a directory, and why you might need this or want this. I did a video about atomicity, so I won't re-explain that. I'll link that in the description. Check that out. But anyway, let's jump into it. Okay, so for this example, we're going to set up a directory. We're going to start by doing deletion first, because this is much easier to explain than replacement. So first we're going to set up a directory, make dir foo, and we're going to touch, foo/bar, and maybe we're going to do make dir foo/baz and touch foo/baz/wat. I don't know. We have, a tree of files here. Now, you might imagine that deleting a directory with rmrf foo is going to do it all at once. And it kind of looks like that. However, the way rmrf works is it recurses downwards and finds the leaflets first and deletes those, and then deletes this, then deletes this, and then deletes this. So at any point in time, you might see a partial set of that directory there. And we can actually see that by doing strace on this and passing that to a log. And then I think it's unlink we're looking for. Yeah, so you can see here, it deleted the wat file first, then it deleted the baz directory, then it deleted the bar file, and then finally it deleted the foo directory. So between, this point here and this point here, you could have observed this directory as being partially there and partially not. So this fails our definition of atomic. Now you can kind of work around this. Let's see, make dir. Boy, we got to recreate this. Let's just put it into one command so that I don't have to do it later. Touch foo/bar and make dir foo/baz and touch foo/baz/wat. Okay, cool. So we have our directory structure again. Now there's a little trick that you can do here to make it look atomic. So in order to look atomic, you would have to observe it before or in the middle or after, and they would all either look like it is 100% there or 100% not. And the trick that we're going to use is we're going to use a different atomic operation to do this. So the first thing that we're going to do is we're going to make a trash can. So make dir trash can. And what we're going to do is we're going to abuse the atomicity of the move command and move our victim directory structure into our trash can, and then we're going to delete our trash can. So what this is going to look like to an outside user is that before you run the command, foo will be there. While it is moved into the trash can, so our first atomic operation, it will not be there, and then we can delete from the trash can at whatever point. So it looks atomic to a user. And so that'll look like, move foo into trash can, and if we strace this, you'll see that it stats trash can, and then it does a single rename at. So there's a single syscall that does this move here. And so that happens in a single atomic action. And so now if you were to try and observe the foo directory, you would not be able to see it. And then you can follow it by deleting your trash can. Now, of course, using the word trash can is maybe not not the most safe way to do this. So the way that I would do this is make a temp directory in the same location as your victim directory. And the reason it has to be in the same directory is you can't move across file systems atomically, and even at the file system layer it may not be atomic, but we're talking about as a program can observe using syscalls. So that's how you can delete a directory atomically. I've used this before while cleaning up things that another system might observe. So like an example of that might be like you install a version of software at a particular directory, and you want to clean up old versions, but you also have other software that's checking whether that version exists or not. And so you would want it to look like it disappears in a single operation. Okay, so that's deletion. Let's cover replacing, so like taking one version of a directory tree and replacing it with another version of directory tree. I'm actually going to show you two ways to do this. One that's much more portable and one that I actually learned while I was researching this video, so stick around for that one. All right, so we're going to make two versions of directories, and we're just going to use simple directories here. So get rid of our log, make dir d1 and d2, and touch d1/v1, touch d2/v2. So we have two directories here, and your naive approach would be to delete one of the directories and move the other directory into that. However, as we said before, there's an intermediate state where you might observe no directory existing at a location. And so that's, that would be armref. Actually, let's get the command at least in place. So that would be armref d1 and then move d2 to d1. But of course, this is two atomic operations. So between this and this, you would be able to observe the d1 not existing. So this does not satisfy our atomicity requirements. Let's actually armref d1 and recreate those. So a trick for this, and this requires setup beforehand. You can't really migrate to this without having to go through a non-atomic move like this. I actually had this same problem when I was maintaining a tool at Lyft, where I was replacing the location of a tool on disk, and so I needed to go through a migration period where I switched from having this structure to the structure we're about to describe. And the structure we're about to describe is symlinks. So you represent your target directory as a symlink. So let's say instead of D1 and D2, that we wanted the outside world to look at a directory called target. So what you would do is you would make a symlink from D1 to target. So if you lsal target, you'll see that it refers, or with the slash, you'll see that it refers to our version 1 file inside of it. And if we wanted to update that symlink, we would do first create a symlink that accesses our target. So we would do ln-new target from D2 to new target. And so if you look now, we have target pointing at D1 and new target pointing at D2, but if an observer tries to look at the target directory, they're still going to see the first version. That's fine. And now we need to do our atomic step where we replace target with new target. So we'll do move new target to target. And so now if we look at this, oh, did I do this wrong? I did backwards. Dang it. Oh, wait, that was right. Oh, I need to do move dash capital T? Yeah, there we go. So move dash capital T ignores symlinks. So this replaced the target symlink with the new target symlink. So now it points at D2. And this was an atomic operation. So an observer before or after would see either D1's contents or D2's contents, but there would never be a state where they don't see any contents at all. And so this is the symlink approach and how you can represent moving one directory to another. Now there's actually a better way to do this with normal directories and no symlinks if you are on Linux, and that is using the rename at to syscall. I actually wrote this little program just to demo this because I couldn't find another program which uses this. Perhaps I didn't look hard enough. But there's a new symlink, or there's a new syscall in Linux 3.15. That should be greater than or equal to, or whatever. Called rename at, and it has this special flag called rename exchange. And what this does is it allows you to swap two files or directories or anything atomically. So you can do this sort of directory swap, but without needing any special symlink indirection. So let's rm target. I'm actually going to download this tool to show you. And yes, I'm on version 2.0. I originally wrote it in Go, and then I ported it to C because I wanted it to not be so big, because it's literally one syscall. There's no reason for it to be, almost a meg and a half. But if we download this And yep. And then we need to chmod plus x that. So now we have our rename exchange command. And if we wanted to move, let's see, tree d1, d2. If we wanted to, oops, yeah. That was me messing up the symlink stuff earlier, so we can delete that. So tree d1, d2, so you can see d1 has v1 and d2 has v2. We can call rename exchange on d1 and d2, and it will swap the two directories atomically. So if we look at the tree again, you can see that it has put v2 into v1 or into d1 and v1 into d2. So it is swapped those two directories. And of course we can swap it again. And if we strace this, you can kind of see what it does under the hood. Send that to a log. Look at our log. Oh, actually, the strace is super simple. I could have just shown it on the output. You know, we execute our program, and it calls rename at2, and it calls it with this special flag rename exchange, and that causes these two to flip. But yeah, pretty cool. Anyway, hopefully this was useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.